And so on this example, this is a system of equations, and they don't specify which way we can solve this. But I personally think solving it by elimination will be easiest, because as you look at the y's, this is a negative 6y, and this right here is a positive 6y. And if you add them up, it eliminates the variable, doesn't it? And so I'm going to go ahead and use elimination to solve this one. So I'm going to add 5x plus 2x, and what do I get? 7x. And these eliminate, because when I do negative 6y plus 6y, it goes away. And then I've got negative 7 plus negative 7 is negative 14. Now what do I do? Right, I'm trying to solve for this variable x right here. Well, the number next to that variable x is the 7, and it's being multiplied, so I'm going to do the opposite. I'm going to divide by 7 on both sides, so x equals negative 2 is correct. But we hadn't solved for y, have we? So I'm going to go back, and I'm going to write the top equation, 5, and instead of x, I'm going to put a negative 2 minus 6y equals negative 7. Okay? 5 times negative 2 is negative 10. Minus 6y equals negative 7. And then I'll add 10 to both sides. And so I have negative 6y equals 3. Have I made any mistakes so far? Then I'll divide by negative 6 on both sides. And so y equals negative 1/2. And so what you should have put in the clicker was parentheses, negative 2, comma, negative 1/2. And what we're saying with this answer is we're saying if I were to graph both equations, the top one and the bottom one, they will intersect at this point right here. Okay, now we're not done once we've solved it. Okay? You still want to check your answer. You should never miss one of these, because you can check your answer, and if you check it and you missed it, you can just go back and do it again. Okay? So let's check our answer. Okay, so here's the problem when we said the answer was x equals negative 2 and y equals negative 1/2. And we're going to check our answer. So we're saying that this is x and this is y, aren't we? So let's plug them in. Now here's the thing, in order for it to be the correct answer, it has to work in both equations. So I'm going to write the first equation, 5x minus 6y equals negative 7. And I'm going to plug in the values for x and y. So I've got 5 times what? Negative 2. Minus 6 times what? What's y? Negative 1/2. And that equals what? Negative 7. Now what we're saying is, when I evaluate all this on the left, it must equal negative 7. If it does, then you got the answer right. 5 times negative 2 is negative 10. And negative 6 times negative 1/2. Anytime you multiply by negative 1/2, you're saying, what is half? So what is half of 6? 3. And so the negative times the negative is a positive 3. Now my question is negative 10 plus 3 equal to negative 7? It is. So you got it right. But now it doesn't matter if it only works in one equation, because it has to work in what? Both equations. So I'm going to write the second equation down. 2x plus 6y equals negative 7. And I'm going to plug in my values for x and y. So I've got 2 times negative 2 plus 6 times negative 1/2 equals negative 7. 2 times negative 2 is negative 4 plus 6 times negative 1/2. When we multiply by a half, we're saying what's half of it? Well, a positive times a negative is a negative, and 6 times a half is 3. And that has to equal negative 7, doesn't it? Is negative 4 plus negative 3 equal to negative 7? It is. So this is also a true statement. And so since it worked in both equations, we did get the right answer.